Hello everyone. So today we would like to present to you our final report of benchmark project-based learning entitled Cartesian Machine with Conventional Control. Next, please. First, let us introduce ourselves. My name is Nisa Warih, and I am the leader of this project. And then there is Muhammad Firdaus Zavani and also Samuel Marcel Sirait as a mechanical. And then we have Amin Muhammad Haikal as a project PIC. And the last one is Afif Aditya as an electrical. Next. So this present would contains by some topics. The first one is introduction, the second one is objective, the third one is work distribution, fourth is flowchart, fifth is electrical and mechanical design, sixth is progress, seventh is challenge, eighth knowledge gain, and the last one is result. So what is Cartesian machine? Basically, Cartesian machine is like a mini CNC. And in this mini project, we have a Cartesian machine with conventional control. This is a mini project based on a Cartesian machine with two linear axes, its x and z axis, which will operate in both sideways, so it can move from left to right or reverse and up-down direction. This project aims to provide students with an understanding of basic electricity, the use of hand tools, and the design and construction of conventional control systems. Next.
Now, objective. The main objective to build a mini Cartesian two-axis machine with two buttons for its controls. And we have key performance indicators. First one, movements. Be able to move right and left with x-axis and up and down with z-axis. Second one, control. Be able to control conventionally with two buttons as it controls. And last, mechanical. Mechanical standing strong and firm. And team role and responsibilities. First, Nisa Ardiningrum as project leader. Her responsibilities: first, time management; second one, team coordination; and third one, stakeholder management. And second, Amin Muhammad Haikal as project PIC. His responsibilities: first, ensuring project complete in time; second, handling mechanical and electrical issues; and third, mechanical and electrical assembly. Third, Muhammad Firdaus Zavani and Samuel Marcel Sirait as mechanical. Our responsibilities: first, handling cutting issues; second, mechanical frame assembly; third, handling 2D and 3D design; and last, Afif Aditya as electrical. His responsibilities: first, handling electrical assembly; second, ensuring motor move correctly; and last, motor and button integration.
Okay, this is a flowchart our project. The first, understanding the concept. Next, project planning, creating a schematic diagram, ensuring the schematic with the concept, providing tools and material, mechanical fabrication, mechanical feasibility check. If the mechanical feasibility check is unsuccessful, the mechanical fabrication process must be restarted. If mechanical feasibility check is successful, next, electrical process. The first electrical fabrication. Next, electrical feasibility check. If electrical feasibility check is unsuccessful, electrical fabrication process must be restarted. If electrical feasibility check successful, Next, the process. Cables and connection according to the checklist, mechanical and electrical feasibility check, and product testing. If if unsuccessful, must be restart beginning. If successful, the product is finishing. Next, this is a electrical design. We use a 12-volt battery connected to push button 1 and push button 2. The push button are connected to DC motor 1 and DC motor 2. Next.
Okay, thank you, Apip. Now, this is the mechanical design based on the PBL technique guide from the Prodi. As you can see. Next. Then, I will explain our project progressly briefly. Previously, our project progress was in assembling the acrylic parts, gathered all the electrical components, but still waiting for arrival of missing parts. Now, our project progress is 100%, with the successful assembly of all mechanical components, electrical work, successful calibration, and finishing. Next. Okay, now document checklist project. Most of them have been completed, but there are still some that have not been completed and are in progress, like this video, Hak Kekayaan Intelektual or HKI. Next.
Okay. During our process, given that we've been working on this project by around 14 weeks, we have met a few constraints. Here are the 6 main issues that we have faced. The first one is component delays. The first issue was simply waiting. Some essential parts were too slow to arrive, so we have to buy it by ourselves. Yet it still takes some time, like bearing, belting, spoon, which force us to pause assembly and adjust our timeline constantly. Like for some online shop, we have to wait for the cargo, shipping, and the other stuff, the other thing like that. And for the offline shop, we have to search first. We have to check if the condition was good or no, and some other things that we have to take some times to buy it. And the next one is the laser cut tolerance. The pieces cut by the laser machine were slightly off, about 0.5 to 1 millimeters inaccurate. This happened because we didn't know the exact machine tolerance beforehand. The next one is linear rod fit. We had trouble with linear rod fitting into the lead screw because the initial sanding wasn't accurate enough. We need to be much more careful with our measurement and sanding to get the perfect fit. And the next one is adjusting issues. We had problem with the adjusting the mechanicals, so components did not fit perfectly, despite being in a correct position. And the next one is the acrylic linear guide. When assembling the acrylic linear guide, the slot on the side of the acrylic turned out to be wider, and we glued it right in the middle, leaving a slightly gap between the linear guide and the slot. As a result, the linear guide, which should be support the acrylic box to keep it straight, actually made the acrylic box humped. Our solution was to add double tip to the linear guide. The next one, and the last thing, is the unstable coupler. Our problem with the coupler that we used was it didn't fully match the DC motor shaft. So we had manually measure it a bit to get a coupler and the DC motor shaft to fit. Then once it was in, the linear rod rotation was unstable. So we had to add a paper to the coupler to make it more stable. Next, please. So, knowledge gain. For around 14 weeks, there are 6 main knowledge that we have gained. The first one is conventional control system design. The second one is practical fabrication and tool handling. And the third one was fundamental engineering principles. And the fourth, project management and risk mitigation. And the fifth, troubleshooting and mechanical maintenance, and the sixth, simply electrical system. Next, please. Here's our result. As you can see, the linear guide that we have to add double tip, and there's some batteries that we have by ourselves, and the DC motor that we have to add some paper to keep it straight. Next, please. Thank you.
That's all from us. Thank you for your attention and see ya in next benchmarking.